Hello TFD Academy fan, welcome back. In this lesson, we are going to kill one projectile motion question step by step. Let's read the question carefully first. A particle is projected at an angle of 60 degrees to the horizontal with a speed of 25 meters per second. We are also given that the acceleration due to gravity, g, is 10 meters per second squared. We need two things. First, the time of flight of the particle. Second, the horizontal speed at maximum height. So, before we start solving, let us picture what is happening. When you throw something at an angle, it has two parts. It moves forward, that's horizontal, and it moves up, then down, that's vertical. This motion is called projectile motion. Now look at the simulation. The object starts from the ground and follows a curved path. That curved path is called a parabolic path. Let's input the values given. The height is 0. The particle is launched from the ground level. Initial speed is 25 meters per second and the angle of projection is 60 degrees. Mass is 0 because it does not affect the answer as long as air resistance is ignored. Then acceleration due to gravity is 10 meters per second squared. Because it's angled, we break the velocity into two, horizontal and vertical. Here's the key. The horizontal part keeps going forward. The vertical part goes up. Gravity slows it until vertical velocity hits 0 at the top. The horizontal velocity does not become 0, but listen. Horizontal velocity never becomes 0. Gravity only touches the vertical. No air resistance, so horizontal speed stays constant. Now let us move from the simulation to the diagram and solution. On the diagram, starts at point O, 25 meters per second at 60 degrees. Highest point, maximum height, end to end. That's the range. But we don't need height or range today. We just need time of flight. Total time in the air and horizontal speed at the top. Remember, time of flight means the total time the particle spends in the air from the moment it is projected until it lands back on the ground. Given u equals 25, theta equals 60 degrees, g equals 10. For the time of flight, we use the formula t equals 2 u sine theta over g. This is used when the projectile starts and lands at the same vertical level. Substitute t equals 2 multiplied by 25 multiplied by sine 60, all divided by 10. Now, sine 60 degrees is approximately 0.866. T equals 2 times 25 times 0.866 divided by 10. 2 times 25 is 50. 50 times 0.866 is 43.3. 43.3 divided by 10 gives us 4.33 seconds. So the time of flight is 4.33 seconds. Now let us solve the second part. Horizontal speed at max height, Vx, equals u cos theta. 25 times cos 60. Cos 60 is 0.5. So 25 times 0.5 is 12.5 meters per second. That makes sense, right? Vertical stops at the top. Horizontal keeps going. So final answers. Time of flight is 4.33 seconds. Horizontal speed at max height is 12.5 meters per second. And that's how we solve it. Rule to remember. Always split into horizontal and vertical. Projectile motion becomes easy. See you in the next one.